This is a recording to show you the solution to 6.40. 6.41 was in the homework, but I did it in the notes for class on Monday. So just to be able to give you a different example, I'm doing solution to 6.40. So this question says that there's an auto service providing oil and lube service. And it's known that the mean time for oil and lube service at the garage is 15 minutes. So the mean is 15 minutes. And it says that the standard deviation is 2.4 minutes. Next, it tells us that the management wants to promote the business by guaranteeing a maximum waiting time for the customers. And it says if the customer's car is not serviced within that period, the customer will get a 50% discount on the charges. They want to limit the discount to at most 5% of the customers. So what should the maximum guaranteed waiting time be? Assume it follows a normal distribution. Okay, so first step, I'm going to draw Z and draw X. X is wait time. We have a mean of 15 minutes and a standard deviation of 2.4. Z has a mean of 0 and a standard deviation of 1. Then we want to give the guarantee to only 5% of the customers. So customers waiting a long time are above the mean. That means we are wondering about this value when this is 5% of the customers. And that's going to correspond to this being 5% of the distribution, and that's Z. So because we have the area under the curve first, we're going to use the normal table first, not the equation. And we're going to look around inside the table for the closest thing to 0.05. And what we see is a result that we've seen before, is that a 0.05 tail, if I looked that up, it would be negative 1.64 and negative 1.65 are the closest. Now notice, those are negative, so that's reminding me that what's happening with those corresponds to a left tail. But I need a right tail. So one way of doing this is to just realize when it's the right tail, it's going to be, if this is 0.05 on the left, and that's a negative 1.645, because it's an average of the two closest, then this value right here must be a positive 1.645. So I just used the symmetry of the normal distribution. You could also have looked up a 0.95, and you would have found a positive 1.64 and a positive 1.65 are equally close to a 0.05, to a 0.95 when we're searching 0.95 for the left tail. So you will still get the same answer. Those are the two ways of finding it. So I'm going to just write search for 5% as left tail means use positive form of 1.64 and 1.65 and taking their average, or search for 95% as left tail, and you will use positive 1.64, positive 1.65 as an average. Either method gives us the same result. So now we know that Z score for a 5% tail on the right will be 1.645 positive. And then our next step is to use our formula x equals mu plus z sigma. So mu was a 15-minute oil change plus 1.645 for the z, and the sigma that we use is 2.4 minutes. And what we should get as our final answer is 18, around, well, this gives us 18.9 something minutes. So if we're giving this deal, if we give them approximately 9-minute guarantee that you don't have to wait more than 19 minutes, excuse me, not 9, 19 minutes, then they won't have to give the special to more than 5% of the customers. So that's how to do the solution to problem 6.40.